Hello everyone. I'd like to tell you how I assembled a main instrument panel that I purchased from Open Cockpits in Spain. Now that will take up about the first 42 minutes of this video. And then I'd like to show you how I built a Boeing 737-800 cockpit around it. All right? Then let's get started. This is a picture of a real 737 cockpit, but I was inspired by the cockpit constructed by Roar Christensen in Norway. He's also the fellow who developed the OC4BA programming system that makes everything work. Open Cockpits manufacture a single and a double MIP, main instrument panel. And after some years saving up for my pennies, I took the plunge and purchased the double panel with everything in it except the monitors and some additional parts that I already had. These are pictures of the panel with everything in place and working. And this is what the basic panel looks like when it's all assembled. I'm hoping mine will turn out just like it. When I unpacked the shipping crate, I noted how well everything was packed and how each piece was protected. Now here's a tip. The shipping crate can also be used, so don't throw it away. I'll show you what I mean later on in the video. Now there's the computer that's going to be running everything with a temporary monitor on top. It's a pretty powerful computer and will need to be, and that is the forward overhead. The captain's yoke and pedals I'd already got, and they are fixed in place, so I'm going to build everything around it. And there are all of the parts ready to be unwrapped. And here's a box containing all the wires and components that are going to be needed to put all this together. I hope. Well, everything is now unpacked from all the bubble wrap. And I can't believe how well Open Cockpits wrapped everything. I mean, everything was really well protected. These monitors had been purchased earlier from Amazon, so everything is here and ready to assemble. The first thing I had to do was print out the instructions and check that all the parts were present. This is a list of all the additional electronic parts that are also needed for the full construction. Next, I needed to make sure I had all the tools to do the job, and the detailed instructions from Open Cockpits illustrates what those are in both English and Spanish. The instructions told me to start with the gear lever and how to attach it to the rib. What the instructions do not make clear is that I needed to cut off the flange on the base. I discovered it interfered later on with the placement of the monitors. So you check for yourself how it's going to fit with your monitors. And a tip here. The spring in the gear lever is very strong, and I found I needed to reduce it. I also wished I'd adjusted these slots as well to make the lever operate more smoothly. You will determine that for yourself. This is also the point where I needed to attach wires. And it is important to follow the color coding to avoid confusion later on. I also tested the connections with a voltmeter to make sure they worked, just in case I needed to make changes. Just being prudent, as this gear lever is about to get buried very quickly, and once it's in there, it's not going to be easy to gain access to it. Next, I assembled all of the parts just as the instructions called for, and importantly, in the order the instructions laid out. Each part has to be put together and then placed and screwed into locations. Now, just in case you're wondering, Open Cockpits have already tested the construction process in their workshops, so the flow of the assembly is straightforward and time-tested. The main instrument panel does not take long to assemble, and all of the parts are clearly marked and labeled. Here are the individual parts of the front of the main instrument panel. And here are the three parts of the panel all joined together with the main braces of the glare shield. This is the lower base unit, all assembled. It will house the two CDUs and the lower display. The next thing to do will be to join these two sections, that is, that part with this part, and then attach the side panels. The instructions are once again quite clear on how to do that, and in a very short time the instrument panel starts to come together. It shows everywhere you need to be able to put the bolts. Now here's the panel all joined together and looking rather good. I was quite pleased with myself. The side panels are in place, and the whole structure is now self-supporting. Here is the view from the rear. There's a very convenient opening there for running wires through, as you will see later on. I must say that the quality of this unit is really very good. It's not made of flimsy tin, but really good strong steel. All the screw holes are pre-drilled and tapped, and everything lined up perfectly and was so easy to assemble. The unit is quite substantial and very well made. Now those parts, that's where the monitors will eventually go. I particularly like the fact that Open Cockpits included an additional side panel, one with all the holes in place to mount a steering tiller. I hadn't expected this, and as I didn't have one, I went ahead and blew the grocery money on the purchase of a steering tiller. Ha! I have not regretted it. This is where the two CDUs and lower display will be installed. And this is the area for the future placement of the MCP and the two FS units, parts that I already had. Very substantial construction. Notice all the holes that are pre-drilled. Really thoughtfully planned. Now, here's the panel in its final place. I measured the location very carefully because at this point I went ahead and screwed the panel permanently to the floor so that it fit around the existing yoke and pedals. I put some of the lighting panels in place to see how it looked, and I think you'll agree it's starting to come together rather well. The captain's side clock is in place, and some of the annunciators are in place also. There's the gear lever in place with an absolutely smashing front plate on it. Some of the lighting switches and the proximity switches are also in place. And there's the first officer's chrono, the clock on the right-hand side. There's the ground proximity switches. Lower display will go there. It really is looking very, very good at this point. I was getting rather excited. Now it's time for the glare shield to be assembled. And here are the clear instructions on what to do and how to do it. There are a lot of small parts that you will need to identify and get ready for this particular section. First, I'm going to have to disassemble my FS and MCP and remove the insides from the original cases, and then find these two pieces of metal to connect the glare shield units together. This is one of the FS units. Now, the instructions weren't too clear about this. Apparently, the main instrument panel had undergone a design specification which wasn't reflected in the older instructions. So I queried Open Cockpit support about it, and they clarified everything for me very quickly. Also, this was the time to assemble the fire warning, master caution, and the six-packs. By the way, the six-packs look the same, but they are not. And to make sure which was which, I connected 5 volts power to illuminate the six-packs. That way I could make sure I had the correct ones on the captain's side and the first officer's side. Now here you can see where those two little metal plates fitted. One here and one on the other side of the glare shield panel. Now this is looking at it from the rear, and all the brackets and everything holding it in place. The illumination strips were also assembled at this time, and the LED strips are put in place and covered with some black gaffer tape. That's to stop excess light bleeding into the area. This is the center strip covered with gaffer tape, and this is the side strip that's covered. Underneath those are the LEDs. Now, just as the instructions call for, here in the glare wings, I took care to ensure I had plenty of wire running from them. The colors are quite important, and I had to refer to the incredibly detailed wiring diagram quite often. More on that later. Now, here is the assembled glare shield unit in place with all the parts, and here are the glare shield wings with some of the switches and the 6 backs roughly in place, but not tightened down yet. That's going across from the FS, the MCP, and to the First Officer's FS. And there's the First Officer's glare wing. And this is where the monitors are going to go. Here I've already got one monitor in place. And I'll show you how I assembled and installed those next. Oh, that's the underside of the illumination panels. The gaffer tape is at the other side of that to direct the LED lights down. Now, assembling the monitors made me quite nervous, actually. It was the disassembly of the monitors themselves. I had to remove the plastic housing and then remove the LED screen and the wiring modules from each of the monitors. It's quite an act of destruction, but quite necessary. So I took a deep breath and jumped in. The monitors that are needed are 2 18.5-inch monitors, a 10-inch monitor, and a 16-inch monitor. All the monitors except the 10-inch monitors are 16:9 aspect ratio, but the 10-inch monitor needs to be a 4:3 aspect ratio. I had a CCTV monitor that I'd purchased from Amazon which worked perfectly for the 4:3. The 18.5-inch monitors were made by Philips, and the 16-inch monitor was a television made by Nevia. The mounting brackets for each of these monitors are quite easy to place. I just had to make sure that the monitors lined up level with the openings. You have to make sure of that, because if they aren't, then the displays do not look right. Here's the rear of the captain's side and the clock on the one side there. And you can see one of the monitors in place. That's the Philips. There's the clock I'm pointing to. And there's the Philips 18.5. There's the center panel. That's where the Nevia television is located. And that's the other 18.5-inch monitor for the First Officer's side. It was the challenge was placing the lower display. That's the 4:3 CCTV monitor I had. It was really tricky to get this in place. And the FMC CDUs for the captain and first officer are also seen here, along with the control switch buttons exposed. Now this is very important. A tip here, I had to make sure that the wires and the controls for the on-off switches were in a place I could get to. For instance, these are the controls for the CDUs and the lower display that arrows are pointing to. Some of the monitors have to be turned on manually each time. The Nevia television, for instance, And if I couldn't find the on switch, then it won't work. So in the case of the Nevia TV, there is an infrared control that needs to be visible in order that the remote control can activate it. This is the infrared sensor and the switch panel for the Nevia TV. And you can see I've identified each of the buttons. This is the on-off switch for the monitor on one side. This is for one of the Philips monitors, and the other is just exactly the same. Now this is what it looks like now. All the display units are mounted, and yes, I did test each screen to ensure that it was still working and would power up after I'd removed the LED panels from their cases. You know, it pretty much destroys all possibility of ever being able to return the monitors for a refund. So, and it's a good idea to make sure that they're working, you know, attach them to a computer before you fix them in place. There's the display units for the captain, the center panel, and the first officer. Below are the displays for the lower display unit and the two CDUs, which you can see are now in location. The glare wings are now in place on both sides. And there's the steering tiller, which I purchased as an afterthought. It does make it look more finished, doesn't it? Doesn't that look good now? What a difference from all those pieces all over the floor. Now my CCTV didn't quite fit, so I used some electrician's tape to cover up the left and the right gaps to make it look more professional. And here are a few views of the main instrument panel from various angles. As looking down it from the first officer's side, looking full on, all the monitors in place. Yes, looking a lot better now, isn't it? Now it's time to look at the wiring. The kit comes with several I/O cards. Now some are for input and some are for output. To avoid getting them mixed up, it's a good idea to put on some labels to clearly identify their function. Then it becomes easy to connect all the flat ribbon cables. And there are several ribbon cables to attach. Here you can see the number that are included in the kit, and here you can see how those ribbon cables are actually connected. The wiring scheme is very detailed, and it's in a PDF file that can be downloaded from Cockpit's website. I needed to refer to it quite often. Now there are several ways to mount the I/O cards. Now I chose to use part of the original packing case. Yes, this one. I painted the board grey and then attached it to the rear frame of the instrument panel, as you can see here. Then I attached the I/O cards to the board in the same pattern as the wiring diagram, so I would have a visual reference. Yes, that's wood that I'm tapping there. The flat ribbon cables were easy to plug in and easy to identify which went into what. I obtained some nylon spacers to stand the cards away from the board, as you can see here. It's not very much, but it's enough to give you a little bit of reassurance. This is the USB servo card, and with some connecting cables going to it from the various instrument panel switches. As I said, the wiring diagram is very detailed and very well drawn. I had it displayed on a tablet computer so I could zoom in on all the detail. Very important when following a particular wire from source to terminal. The trim Corrie switch was a bit confusing at first, but Open Cockpit support clarified it for me. I did have to solder a couple of wires onto it, just like this. I also discovered that the wires going into the USB servo cards needed to be plugged in according to the color. And here is the proper orientation. Brown, orange and red, and this is the servo card with the ribbon cables in place. As I said, I identified each of the input and output cards with the little label. That way there would be no confusion. This is the input for the first officer. And here is the captain's input. And that one is the output connector. And down here is the dim control. It's coming together, but I admit it does look a bit of a mess. There were so many thin wires to add and connect, all of which are very small, so I used a magnifying glass to make the job so much easier. This is the top of the captain's side glare shield in place. And there's the place for all of the checklists. The first officer's side isn't complete, but it does show you the extension of the wires needed. There's the back of the clock for the first officer. And there's the clock for the captain. As I added the wires, I stuck to the color coding. Yes, starting to look more and more like spaghetti, doesn't it? I really will have to tidy this up. But you can see that this is a job that requires a lot of patience. Those are my tools you can see there. Strippers, pliers, soldering kit. At this point, the wiring was just about finished. I'm hoping that it will work. And on the side there, on the right, is where I placed the power supplies. Each wire must be placed in its exact spot, otherwise it won't work. It's incredibly detailed. And don't look to get this finished in 5 minutes. It takes a lot longer than that. Each group of wires were taped together and also identified. There are the power supplies in place. The top one was for the forward overhead, and the bottom one is to power the main instrument panel. There are 3 voltages to deal with here: 12 volts, 5 volts, and 3.3. It's best not to get them mixed up, eh? There's the top one. There are all the voltage wires coming out and being distributed to the various parts of the instrument panel and for the forward overhead. Now it's time to add main power to the panel. I'm also going to need to cover up all my wiring mess. Can't leave it looking like this, so I added a standoff piece of wood here, and another one here. Then I covered the whole thing with another piece of the packing case, painted grey again, and oh, it does look so much better. I also covered in the gaps for the pedals on both the first officer's side and the captain's side, and painted them grey as well. And next I added some power strips for all the extra modules that I'm going to need to plug in. Now it's time to connect the computer and align all the monitors. All the USB cables need to be plugged in, and I used every one of the USB ports on my computer. I even needed an external USB hub. I've got 3 graphic cards in this computer as well, with a total of 9 displays to run. Each of those would need to be connected as well. There are a lot of things plugged in this. That's the back of the MCP and FS. There's the 2 power supplies, and there's the main computer. Now let me tell you what the computer has, and of course it's going to have to be powerful to run everything that I've got. It has an Asus X99 Deluxe motherboard, an Intel Core i7, the 5820K Extreme 3.3 GHz processor, 4 Corsair Dominator Platinum memory chips, giving me a total of 32 GB of RAM. It's a silent Pro 1000 watt power supply from Cooler Master, 3 GB GTX 1080 graphic cards with 8 GB of DDR5 RAM on each card, and then there's a couple of crucial solid-state drives. And why is it necessary to have such a powerful computer? Well, here's what's plugged into it. I've got an Epson projector. I've got 2 Philips monitors, for the main panel. I've got that 16-inch Nevier TV, 10-inch LCD color multimedia CCTV monitor, 2 Hans D flat panels, 28-inch ones for the left and the right views, and 2 small screens that are on the CDU FMC modules. There's an awful lot. That's a total of 9 displays attached. This is how I connect them. There's 3 displays per graphics card. Now the projector and 2 side panel windows are on one card. The 3 display panels that make up the main displays are on another, and the 2 tiny screens of the CDUs with the lower display are on the third. Now it's important that I arrange the multiple displays into some sort of order, and this is what I did. On the top are the monitors for the left and the right view windows. Then there's the 3 main instrument panel monitors next to each other, and next to the main monitor, which is the projector, and that's my primary monitor. Underneath is the monitor for the lower display unit, and finally the left and the right CDU screens. Now the job of assigning the panels. I started P3D and then chose my PMDG 737 aircraft. It's a fiddling process, but once the 2D cockpit view is selected, then each display panel has to be moved, resized, and lined up to match the spaces in the instrument panel. Here you can see the captain's display being moved into place. And then this is how the monitors are arranged. There's an 18.5-inch screen here, then the Nevia 16 screen, and then the other 18.5-inch Philips. Then the left CDU screen, followed by the lower display unit, and then there's finally the right CDU screen. Getting the correct pixel settings is also important, and these are set both in the graphic card settings, that's the NVIDIA settings in my case, as well as in the P3D graphics section. These are the ones which work best for me. The three screens of the main instrument panel are set to 1366 by 768 pixels. The two CDU screens are set to 1024 by 768, and the 10-inch monitor is first set to portrait, very important, and then to 768 by 1024 pixels. Now it's time to test the main instrument panel's connections. I use Cockpit SIOC software to run everything, but in particular I use Roar Christensen's OC4BA scripts to make all the connections between the simulator and the Cockpit's modules. Now here is the screen showing all the cockpit's configurations with the modules I have connected. Here is the main instrument panel with all the screens lit up and active. So now it's time to see whether the buttons and switches I spent so much time wiring up are actually working. If I made any mistakes in the wiring, here is when I'm going to find out. Now these are the test screens for the SIOC monitor. This screen shows no lights on, and this screen shows that all the lights should be on. So let's try it out. I click on the all on and it looks like it works. So here's the finished main instrument panel with all the individual screens filled with the appropriate and corresponding 737 screen. It does look impressive, doesn't it? Look at that, all the buttons and lights are lit, even on the glare shield. So here is the finished main instrument panel with all the individual screens filled with the appropriate and corresponding 737 screen. It does look impressive, doesn't it? Well, now that the main instrument panel is finished, I think it's time to build the rest of the cockpit. So here we go. Now, I use this convenient measurement chart that I got from Open Cockpits. It was drawn by Pedro Biblioni and it is very accurate. Muchas gracias, Pedro. Now, in particular, I needed to know the angle and position of the side strut, as indicated here, as this will help me with the next bit of construction. Using some 2-inch by 3-inch studs, I constructed the side strut in just about the same position as a real 737. After making sure I had the correct angle, I bolted it to the side of my main instrument panel. Now the placement and angle has to be the same on both sides. Now this was the tricky bit for me because I'm not much of a carpenter and I didn't have any fancy woodworking equipment. The horizontal bar you see here is at an angle, the angle that the forward overhead has to be, as this diagram shows. In addition, the gap between the horizontal bar and the top of the glare shield must also be exact according to the real 737. Oh, and on top of that, it is nice to have it perfectly level as well. Next, I needed to add the short piece needed to support the forward overhead and a vertical support post that will be the actual rear of my cockpit. and another horizontal beam to complete the job. Next, I need to determine the position of the side sections, and I do that by marking off the positions using some masking tape on the floor. Next, I add a couple of horizontal pieces to the upper and lower ends of the side windows, on both sides. I'm actually going to add a monitor in each of those places to represent the side views. This bracket is going to hold my side view monitor in place. Now here is the left view monitor in location, and it's retained with a temporary bungee cord. This is the armrest in place, and here you can see the vertical piece I added to complete the captain's side. Now this is the monitor in place for the first officer's side view, with the finishing vertical piece of wood in place. Now it's time to mount the forward overhead, and the gap between the two horizontal beams is exactly that of the overhead itself. The forward overhead is held in place with a total of 4 angle brackets. The drop and finish position of the forward overhead is exactly the same as a real 737. It was at this point that I decided to add a small panel to hold the IRS switches. I know these belong on the rear overhead, but I don't have enough money for one of those, so I have to make do. The wires connecting the IRS go to this BU0836X, which is a 12-bit joystick controller made by Leo Bodnar Limited in Silverstone, Northamptonshire. This is what the forward overhead looks like from the captain's seat. Using some very thin plywood that was going to be thrown away by a timber merchant, I started to make the curved ceilings and held them in place with some good strong clamps. Here you can see the cockpit ceilings in place. I needed to cut a special piece to cover the gap in the front at the bottom of the overhead panel, and some heavy-duty staples managed to hold it in place. Next, I started the construction of the side shelves. Very important if this is going to hold my can of beer later on. I actually used some more of the packing case and some thin hardboard for this. It's all starting to come together now, and it looks more and more like a cockpit. I considered painting the ceilings, but I decided instead to buy some cheap grey vinyl leather cloth upholstery fabric from Amazon, along with a litre of PVA adhesive. Using the brush, I painted the glue onto the plywood and then pressed the upholstery fabric onto it and used clamps and clips to hold it in place until it dried. This is the result. Much better than paint, I think. I did the same with the lower side panels on both the captain's and the first officer's side. For the top surfaces of the side panels, I used some grey vinyl flooring and more PVA adhesive to bond it. This is the result. This dimmer switch was added to control the overhead cockpit light, one on the captain's side and another one on the first officer's side. The main forward strut for the cockpit window needed to serve the additional purpose of being a channel for all the wiring from the overhead to the computer itself. I also covered the outside with more of the cheap vinyl fabric covering. Since sound is very important for a simulator, I mounted stereo speakers onto the top horizontal beam. Using some 1-inch foam, I covered the area around the side windows and the armrest. Nothing like a little bit of comfort. Then, using more of the grey vinyl flooring material, I covered the foam and the armrests along with the front right and left struts. The final touch was to cover the right and left exposed holes, as well as the vertical supports with more vinyl flooring material. It just finishes off the look of it. Now, when you look at the real 737 cockpit, you can see the navigation tablet is mounted there on the left. In most 737s that seems to be on the side, but I decided to put the tablet mount right onto the yoke, as that is where the charts are usually found and clipped. From Amazon I purchased this NovoPad bracket and discarded the arm part, as all I needed was a different way to affix my small Windows tablet holding my Navigraph charts to the center of the yoke. Once again, a small angle bracket came in very handy to affix the back of the NovoPad to the yoke. And here is the tablet in position. And it will tilt and angle as well as rotate as needed. Here is the tablet, open and active with the airport chart for EGNX, which is East Midlands Airport. And it's showing the live position of the simulator aircraft at the stand. Now, I tested this and found that it does not impede the normal use of the yoke. Now, I had my pilot pal from Ryanair come in and use it, and he said it was perfectly positioned and posed no control issues. Now it's time to do the finishing. Well, here's the cockpit as it looks now. I've got all of the material on this. I've got my side shelves there. Phone, keyboard is all in place. And I've even got trims around the edges, you know, this area here. Make it look halfway decent. This is the better looking side. It was inevitable. I make mistakes on one side and then don't replicate them on the other. I'm going to be getting a new yoke in there for the first officer. So then I returned the throttle quadrant from Flight Simulator Center in Italy into its place. And the last piece is the pedestal, with just the captain's side set of radios and navigation units. The first officer's side is just a dummy. This little add-on is my own construction and contains buttons for quick control of pushback, ATC, and even switches to go between HBA and inches of mercury and between radio and barometric minimums. Now for the big process of starting the simulator. First I turn on the overhead lights, and here is the finished cockpit with the new yoke and pedals for the first officer in place. And there's the checklist on the first officer's yoke. It does make it look rather finished. Oh, by the way, the dining room chairs are not a Boeing standard. Now, to start all of this, I first need to add power to the overhead strip that powers the projector and the speakers. Here's the switch. It's a bit of a tight squeeze, believe me. Anyway, and there's the switch, and turned on. Now I turn on the main power for the simulator itself. And there it goes. Next, I turn on all the switches to power up the strips holding all of the electrical equipment, one by one. And last, I turn on the computer. Now this is the remote to turn on the projector, which is the main screen. So click and off it goes. And the next one is the remote to turn on the Nevia television. And notice here that the red light goes out. And there. Now we know that all the screens are on. And the computer is all powered up. Now it's time to squeeze past and to enter the cockpit. And notice how all of the monitors are live and reflecting the blue desktop of the Windows computer. Now first I need to do, of course, is go into SimBrief, and I need to load a flight plan. So click and away we go. And of course I need to power on my tablet computer and then load the Navigraph charts, the desktop charts. The next thing I need to do is to start up Active Sky and then start Prepared 3D. And once the scenario has been chosen, I'm going to use PMDG 737 with the Ryanair livery. That's when I activate the OC4BA version 4 add-on, which then connects all of my simulator cockpit with the main simulator software. Once the simulator software is connected, now I can turn on the battery power for the overhead. Everything lights up. Here's the fuel pump switches. And then turn on the APU, the auxiliary power unit. And look at that little gauge on the center there, showing the EGT. You're going to see that actually move. This is the beauty of using Roar Christensen's OC4BA, because whatever the software is doing, it sends out the commands so that it activates the hardware of all of my Open Cockpit's modules. So it's really quite remarkable. I couldn't get over noticing this. In a moment the EGT is going to go down and steady out, and then I can switch the whole unit onto APU. There we go, listen. And all the sound comes through. Now, galley on, emergency light switches, no smoking, fasten seat belts, and window heat, hydraulic pumps, and there are all of the, and that's the APU bleed. It's now allowing air conditioning to flow through. Now you can see all of the panels here are all connected and reflecting the actual flight deck. MCP and the FS units that you saw just there. All of the display units. There's the lower display and the two CDUs. And the overhead panel showing everything that's going on. Now that little switch is for bank angle. That was something I added. There's the view out of the left window, the front, and there's the right window. Notice the vehicles as they go from left to right and right to left. They go off screen and show on the others. It works really well. There's a bus crossing over the front and then going off to the right. Now let's have a test flight, shall we? There's the view out of the left window. Let's sweep forward. And that's the view on the horizon out of the front window, looking over the top of the MCP. This, by the way, are the Canadian Rockies. Early in one morning, I was on my way to Calgary on a test flight. Magnificent scenery. And here's the wonderful main instrument panel. That's the view outside of my right window. Well, thank you for watching, and I hope this has proved useful for you in building your own cockpit.